Hi guys, welcome back to the channel. So today we are coming with new day of the problem, that is the shift 2D grid. So what is the problem stating? I will tell you in my words too, and you can also read the problem. So the problem tag is easy, and here is the problem. So basically we have given a grid of size n cross m and another value k. So we have to perform k operations on that grid. Suppose the grid is 1 2 3 4 5 6 7 8 9. In each operation we have to move one element or every element of this array by one value or by one position. Like this element would come here, this would come here, and this would come here. This is here, 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 and this would come here. So this is the one operation that we have to apply. Okay, so now the final grid would be, this is empty first of all. Now this here one move, either here two move, here three, here 4 5 6 7 8, and here is a 9. So this is after one operation. As like we have to perform k operations. Suppose if we have to perform 3 operations, then this one move to 3 places, like first, second, and third. This is the one location. Now the second location would be this, third location would be this, likewise all. So now how can we approach in this problem? So one key observation is there. One key observation is this: if we apply a operation on a particular element, or during a operation, if we have choose a element, then the new position of that element would never be conflict to new position of another element. So we have freely made the operations on particular element, because this position is unique, every position is unique, and we are adding some unique some common element to every unique position. Like if we are adding x to 2 or x to 3, or sorry, x plus 1 to x plus 1 to 2, then these two values always be different. Okay, so we are independently add the k value to every element, the resulting position will not be conflict. So this is the main key observation. Now the idea, how can we move, or how can we apply, or how can we calculate the particular position of the element after k operations. So to do that, first we find out what is the current position. So current position is I comma j. So first we have to write this ij into one number. Like you can say this is the 0th position, this is 1 position, this is 2, this is 3, this is 4 5 6 7 8. Okay, likewise if we have n cross m matrix, then first element is at 0 and the last element is at n into m minus 1 location. Okay, so this would be our original position mathematics. Now we have to add some k in the original position. Like if we add t, then we have to move this t to t plus k. Okay, so now we have to find what would be the t plus k in terms of I comma j. Okay, so two things we have to find. First we have to find this value, this position value. Like we have given only I comma j position, we have to find the one value for I comma j, what is the actual position, like 1 2 or 3, and after finding that position we have to find the new I comma j after adding k in this value. Okay, after adding k, this would come t, and we have to convert this into the I comma j. So this is all we have to find. So now for finding the current position from I comma j, what formula we can have. So let's think here in the matrix. So this is 0 1 2 3 4, 0 1 2 3 and 4. Okay, so this is 5 cross 5 matrix. So if we are on location this, okay, so here how many rows we have completed? We have completed one row. Okay, so if we are on the ith row, then we have completed I number of rows. Okay, I number of rows. And how many element in particular row? There are m elements. If the matrix is n cross m, then there would be m elements, I into m. Now the position of this element in the current row, so that would be j, that would be j. So this is the position of our current element. Okay, so in this way we can find the position. Now we have to add k in this position. So after adding k, some value t would come. Okay, now the cases are, the t may be present somewhere here or somewhere here, or maybe out of it. If it would present out of it, then our value start from there. If this is total value is like in this example is 5 cross 5 matrix 24. If we have 25, then our value is this. If we have 26, our value is this. For 27 this. So likewise we have. So how can we achieve the new values? So we can use the mod one. So whatever the value we are coming with, we can do it percent n cross m. Okay, so what it would give? So if we are on the, now this t value would be 24. Okay, this t value would be 24 and percent by 25. So this would give remainder 24. We would remain here. But if this t is 25, then percent 25 is 0. We will move there. Likewise, if this is 25, 26, 27, always after completing one cycle, we are remaining with the remaining positions that would come start from starting of the first row and first column. Okay, so likewise if we have completed 2 cycles, 3 cycle, we have received the new value. If we do percent with or mod with product of the n cross m, so we would come with the new position. So this would be the modulated t. Now we have to convert this t into the I comma j. Now how we can do that? So we know if we are on this position, then we have to first find how many rows has been completed. After doing that, we have to find the row in which what is the position of column. Okay, so how can we do that? We can divide this value with m. Okay, so whatever the quotient will come, this would be our row number, this would be our row number, and after doing mod with this, then whatever our value would come, this would be our column number. Likewise, if we have 3 4 5 6 7 8, for 8, if we divide by 5, so it would come 1, and if we would divide 8 with 5, then it would come 1. Likewise, if we divide do percent with 5, then it would come 3. Okay, so 0 1 2, we are on 2th position, but we have to find this. So basically for 8, no, this is not 8, this is 7, because we have to start from 0. Okay, 0 1 2 3 4 5 6 7, so this would be 7. So 7 by 5 is 1 and 7% 5 is 2, so this column would be 2 and the row would be 1. So with that formula we can find the I comma j. Now it would be more clear in the code part, so let's move to the code. So here what we have did, we have find the value of n and m. This is the number of rows and number of columns, and this is our answer vector. Okay, so now we have calculated the product n into m. Just we are needing for doing some steps in the future. So here we are first calculating the position, current position, as I have told you, that would be the I into m plus j. Now I would add k into the current position. Now do position percent product. Okay, so what it would come, it would give us the modulated position. If this any cycle would complete in the current position, then we will get this value here. Okay, so now we would divide the position by m and percent by m. Okay, so this would give us the exact ij value that we would store, in which we can store the grid ij. Okay, so this is our answer matrix, we can calculate in that way. So I think the problem statement and solution both are clear to all of you. So that's all about this video. Thank you.